Hello, my dear students. I'm Lizelle Henson, your math tutor. Today, I'm going to discuss linear equation, but just a chunk of it, which is the slope-intercept form of linear equation. This linear relationship are all around us, from how fast we travel to how much we save or how much we spend. And to describe this relationship, we use a special equation called the slope-intercept form. So at the end of this topic, we're going to, or you should be able to identify the slope and the y-intercept, be able to interpret slope as rise over run on a graph, determine whether the slope is negative, positive, zero, or undefined, and finally explain the meaning of slope in real life context. I will introduce to you this equation y equals mx plus b, where m is the slope of the line and b is the y-intercept of the line. This form helps us quickly see how a quantity changes and where it begins. The value m tells us the rate of change or the slope, while the b shows the starting value of, or it is called the y-intercept. So with this form, we can easily graph and interpret real life situations. And the rise over run, the rise tells us how much the line goes up or down and how much it goes left or right. In this case, we have 2 points, 1 and 2. And notice that we have along or going to the right, we have 1, 2, and 3 points. So the run is 3 in this case. And going up, we have 1, 2, 3, 4, 5. So our rise is 5. Therefore, our slope is equal to 5 over 3 or 5/3. For example, you're moving on this staircase. You can see that we can form a line in here. So this line has a slope. How much you're moving up and how much you're moving towards a certain point or moving either to the left or to the right. So the movement, the upward movement is what we call the rise, and the horizontal left or right movement is what we call the run. So the slope is defined as the rise over run. If the line rises as it goes, if the line rises as it moves to the right or to the left, then we have a positive slope, like in this case. We're moving up from this level. We're moving 1, 2, 3. So 3 points up. And then we're moving also 1, 2, 3, 4, 5, 6, 7, 8. So that's 8 points. So we could say that we have 3 over 8 as our slope. This is a positive slope. And then for the second line, the violet line, we have 1, 2, 3, 4, 5, 6. So we have 6 as our run, and our rise is 1, 2, 3, 4, 5, 6. So we have actually a slope equal to 1 because it moves 6 points up and 6 points forward to the right. Again, it's a positive slope. But then if we have a line, in this case, this one, wherein the rise is equal to 0 because there's no change or there's no moving upward. At any point along the line stays horizontal. This means that your rise is equal to 0. And so this is what we call a horizontal line. So every horizontal line or any line that is parallel to the x-axis the slope would be equal to 0. And here comes the fourth line, wherein as you move to the right, for example, this point here, when it moves to the right, the line is or falls downwards. It's like you're going down a staircase. So once you're going down a staircase, you have a decreasing slope. And you can also again compute for the rise over run. Moving downwards, we have 1, 2, 3, 4. So the rise is equal to 4. And moving to the right, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 4 over 9. That's our slope. Is going downwards, then we have a negative slope. So in this case, right here, we have 1, 2, 3, 4, 5, 6, 7. So our slope can be written as 7 over, and we move to the right, going to this point here. We have 1, 2, 3, 4, 5, 6, 7. Okay, so our slope is again equal to 1. However, for the orange line right here, we have a slope that is undefined. Why? Because your run is equal to 0. There's no horizontal change. It doesn't move either to the left or to the right. This means that our denominator is equal to 0, or the run is equal to 0, which is an undefined, because any number divided by 0 is undefined. So take note, if the line is horizontal, our slope is 0. And if the line is vertical, we have a slope that is undefined. We have y is equal to 3x plus 2. Now, how do we graph this line? We start with a y-intercept, which is located at b equals 2. In this case, it's located right here. And then from this point, we go up 3 points. Why? Because the m that is equal to 3 is also equal to 3 over 1, which means that you have 3 points up and 1 point to the right because it's positive. All right, so we have from 2 as our starting point, which is the y-intercept. We move up 3 points, 1, 2, 3, and then we move 1 point to the right. And then we connect these 2 points. We now have a line. That line is y equals 3x plus 2. Take note, in this case, it's increasing. Our slope is positive. For the next example, we have a slope that's negative. This means that your line is decreasing. And we locate our B, or the y-intercept. It is located at this point right here. And so our slope is negative 3. It means that we have a negative 3 over 1. So we go down 3 points from y equals 1 right here. Go down 1, 2, 3, and then we move to the right here. So this is our line. We connect these 2 points. Oops. We connect these 2 points. And then we have this line, negative 3x plus 1. So we have y equals x minus 1. This means that our slope is 1 because any variable without a coefficient, it is understood that the coefficient is equal to 1. This means that our slope is 1. Or we could also say our slope is equal to 1 over 1. So we have 1 point moving up and 1 point moving forward to the right. So starting with the y-intercept, which is equal to negative 1 right here, okay? And we move 1 point up and another point to the right. And then again, we connect these 2 points. We have that line y equals x minus 1. Finally, we have y equals 3 over 2x plus 1. This is easy to uh, to say that our slope is equal to 3 over 2, right? 3 over 2, what is our rise? Our rise is equal to 3. And the run is equal to 1. Oh, sorry, 2. So starting from the y-intercept, b equals 1. So from here, we go up 1, 2, 3, and then move 2 points to the right. 1, 2. So this point right here, we connect that, and that is our, oops, okay, that's it, I think. Made it. So that's your y. Every time you draw a line, because that line goes infinitely up and infinitely down, it is better to put arrow on each end. That's our slope, and that is what point slope form is, how we interpret it mathematically. Now, for example, we have this situation right here. Maria saves $10 a week. She already has $20 saved. How are we going to express this in a point slope form? Notice that already, the word already means that it's the beginning. So at time equals 0, okay, starting point, you have, or Maria has $20 already. So writing our equation, we have y is equal to, that's our b. B is $20, and our slope is equal to 10. So our equation would be 10x plus 20, because it's the word save. But if it is spent, then it should be negative 10. If Maria spends $10 a week. So it's the opposite of saving, right? Therefore, you have a slope that's negative because your money is actually decreasing because you're spending it. Next example, at 5 a.m., the temperature is 50 degrees Fahrenheit and increases by 2 degrees every hour. So identifying our slope, it should be equal to our slope with the word increases by 2 degrees every hour. So that is our slope, because slope is the rate of change, meaning the change in temperature per unit time. So you will have a slope that is increasing 2 degrees, and that's 2x, where x is your time, plus the temperature is 50 degrees. That's the starting point. So our y-intercept should be 50. Okay, so that's our equation. No, I'm sorry, this is not m. This should be equal to y. Sorry for my handwriting. And then we have another example, our last one. We have a person loses, oh, we have a double word here. Loses 1.5 kilogram per week and weighs 70 kilogram initially. So take note of the word initially, that's the beginning. This would be our B. So our B right here is 70 kilogram, and our slope, because of the word loses per week. So it's a rate of losing weight. And so since it loses weight, we have a negative slope. So negative 1.5. Therefore, our y is negative 1.5x plus 70, where our x is the number of kilograms that's losing per week. And so we've learned today that the b for mx plus b equals y is the y-intercept. It is the point where the y, or the line, crosses the y-axis. M is the slope. It is positive when increasing. and negative when decreasing. 2 points create a line. Slope can be solved such that slope is equal to rise over run. X-intercept is, I haven't discussed this, but I would like to include this one. X-intercept, it is the point where the line crosses the x-axis. In this case, your y should be 0. And so your coordinate, the point, should have the coordinates x, comma 0, where x is any point on the x-axis. We have also another thing that we've learned. Vertical lines are parallel to the y-axis. Their slope is undefined. Horizontal line, such as this one, slope is 0. Vertical line, such as this one, the slope is undefined. So for a paired activity, I would like you to work in pairs, create your own real-life situation, and exchange with another partner. Interpret such that for each situation, what we did a while ago, okay, you're going to write the equation and identify the slope and the y-intercept. So the m, what is the b? And then explain what the slope and y-intercept mean in the context of the problem. That is